Okay. May, June 2023, paper 4, variant 2. Yeah, question 1 shows a helicopter which is stationary at a height of 1500 meters above the ground. State two conditions necessary for the helicopter to remain in equilibrium. What are the two conditions? Hmm. حد فاكر؟
Upward force equals downward force.
Upward force equals downward force, so we can say zero resultant forces. Okay, what else? Hmm. Yeah, forces or zero resultant forces. What else? What's the other condition? Hmm. What is the other condition?
اللي هو الانتي clockwise والclockwise ولا ما تنفعش
بالظبط
هنا؟
بالظبط، صح. انتي كلوك وايز ايه بقى؟
force
م-م.
لا rotation
اه،
لا wait
انتي كلوك وايز وكلوك وايز بنسميهم moments، صح. So
صح.
zero resultant moment as well. طيب. The mass of the helicopter is 3200 kilograms. Calculate the change of gravitational potential energy as the helicopter rises from ground to 1500 meters. Gravitational potential energy, GPE equals. GPE equals. What's the equation? يلا شوف.
Eight.
MGH. Okay. MGH. Mass. Okay. Times the G, which is 9.8, and the height 1500. يلا, someone calculate it for me بسرعة. Yeah. The gravitational potential energy should be, and write it as a standard form. It would be a huge number, definitely. So we need to write it as a standard form.
I got 4.7 times 10 to the power of 7
ماشي. 4.7 times 10 to the power of 7. Do not forget the unit. What's the unit?
joules.
Joules. Okay. Vertical time graph for a parachutist. Okay. He jumps from the balloon at time 0 and reaches the ground at time B. The point A indicates when the parachute opens. On figure 1.2, label the point on the graph where the acceleration is 0 with 1, negative with 2, decreasing with 3. We want a point at which the acceleration is 0. Where does he have a 0 acceleration? Huh. 0 acceleration.
The
Hmm?
straight line before curve at the beginning.
Straight line before the, you mean at this point?
Yeah,
No.
like just before the curve, because then it'll be
This is this is
positive.
not this is not 0 acceleration. At this point, it's not 0 acceleration. This point is constant acceleration. Okay, this point is constant acceleration. What do I mean by
So would it
0?
be the
Hmm? What
would it
did
be the part before a straight line?
exactly before a straight line? Well, the part which is a straight line. You mean this part?
Yeah, the part that yes, that's what I mean.
So, or you can say this part as well. Both of them are a straight line. Both of them have 0 acceleration, meaning that both of them were traveling with a constant speed. Which part is a negative acceleration? Negative acceleration.
واحنا نعمل كل 1 ولا
لا.
بس
Where's the part with the negative
ماشي
acceleration?
فهمت
Isn't negative اللي هو نازل تحت رايح لبي؟
هنا negative acceleration, meaning the speed is decreasing. What about decreasing acceleration?
It's the curve.
The curve, صح.
So,
Decreasing acceleration, this is the curve. Okay. Good. Explain in terms of forces the changes in motion which occur from when the parachutist leaves the hot air balloon until point A. Okay, we want to go up till point A, and that's it. The change in A, in motion in terms of forces. how does his motion change in terms of the forces? Can someone explain?
And when like at the start, the acceleration like it's like في الأول خالص like it's
Hmm.
starting to increase شوية and then it starts decreasing. So when the speed is increasing, wouldn't the resultant force also increase?
Resultant force, لا, resultant force would decrease. When the speed increases, the resultant force decreases and will stay y now. But initially, the acceleration wasn't increasing. Initially, the acceleration was constant. Initially, he was falling with a constant acceleration, or his speed was increasing with a constant acceleration, because the only force acting on him was his weight. Okay, so initially, hmm, okay, um, speed was increasing with a constant acceleration. Constant acceleration, since the only force acting on him, only force acting on him was his weight. Was his weight. Okay. Then, as his speed increases, what happens? What's one of the forces that increases as his speed increases? Hmm.
Air resistance acts
Yeah,
upon him and
exactly.
slows him.
Nah, don't say slows him down. Let's see. As his speed increases, air resistance increases. Okay, this is the resistive force. And therefore, what happens to his resultant force? Hmm. What happens to his resultant force? Decreases. Okay, when the air
Decrease?
decreases, okay, as the air resistance increases, the resultant force, okay, decreases. That's why he had a decreasing acceleration in part three. That's why he had a decreasing acceleration. So his speed is still increasing, but with a decreasing acceleration. Okay. A resultant force decreases. We can say that his speed increases. Okay, increases with a decreasing acceleration. Okay, until hmm, until the air resistance becomes equal to the weight. Finally, the air resistance becomes equal to his weight, in which hmm, when the air resistance is equal to his weight, that's why we said he will reach an equilibrium, a state of equilibrium, meaning that zero resultant forces are acting on him, meaning that he will be falling at a constant speed. Uh, Air resistance becomes equal to his weight, so therefore zero resultant force acting on him, and then he falls with a constant speed, with a constant. We can name it terminal velocity, okay? You can say he falls with a terminal velocity, constant speed, it's okay. Both of them are the same. Okay, حلو. Any questions? Also, as extended, this is an extremely important question. Okay, this question is very, very important. Okay, it has to do with the motion, it has to do with forces, and this is a very common question for our exams. So you must be able to solve it on your own in terms of forces. Oh, like his speed increases since the only force, initially his speed increases with a constant acceleration since the only force acting on him was his weight. And then you have to state that as speed increases, the air resistance increases. And then when the air resistance decreases, the resultant force decreases. Therefore, he's falling with an increasing speed but decreasing acceleration. And then the air resistance increases up till it becomes equal to his weight. Therefore, he falls with a constant speed. Okay, good. Yeah. Next question. Calculate the kinetic energy immediately before it's caught. What's the kinetic energy? Can someone remind me?
half mv
Okay,
squared.
Okay. Half mv squared. يلا. Kinetic energy equals half mv squared. يلا. What are the numbers I'll substitute with?
M is 160.
So half times 160 times 18 squared. صح?
Yeah.
That's wrong. Why?
Wouldn't we
Which
have to change it into kilograms, صح?
You have to change it to kilograms. You must change the 160 grams divided by 1,000, which would give you 0.16 kilograms. That's a must because this is the SI unit. Okay? Half times 0.16 times 18 squared. Can someone find the answer? يلا. What's
25.92.
25.92 يعني you can write it down as 26 joules.
هو أنا لو أنا كتبتها بالجرامز أنقص درجة واحدة ولا كام درجة؟
Um, probably you'd lose 2 marks مثلا.
2 marks من 3.
Hmm. طيب, calculate the average force exerted on the ball. It takes 0.12 seconds to catch the ball and bring it to rest. What is the average force acting on the ball? Any ideas? How can I find the force? How can I find the force?
isn't force mass over acceleration.
Mass over acceleration. Wow, you haven't been studying. Force equals mass times acceleration. Okay. Actually, there are two ways to solve this question. Either you say force equals mass times acceleration, or you can solve it using the impulse. Force times time equals the change in velocity, mv minus mu. Okay, both of them will give you the same answer. Initially, you need to find the acceleration. So you'll say mass, which is 0.16 times the acceleration, v minus u over t. V was 18, u, final speed 0, over t, which is 0.12. Okay. You can calculate this. Someone calculate it for me, please. And force times 0.12 equals يلا, 18 times 0.6 minus 0. Yeah. What's the final answer? The force
24 newtons.
24 newtons. Okay. As the student catches the ball, she moves her hand backwards. Explain the effect of this action on the student's hands. Why does she move her hand backwards as she catches the ball? Ah, yeah. It has to do with momentum and impulse. Why does she do that? Any ideas?
She's trying to like increase the force.
لا 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 لا, not increase the force. She's actually trying to decrease the force. Why? Oh, how?
So she puts her hand back
Hmm.
like the ball is going towards her or what?
Yes, yes, the ball is coming towards her and she wants to stop the ball. She wants to catch the ball. When she
Okay, so if
catches,
the ball, it would be less of an impact, so it won't like, be as painful.
which is correct. So how does it become less of an impact? How does it exert less force on her?
Is it because
Because
like the
it took
time?
a longer time to reach
Longer
her.
time. Thank you.
عشان ما توجعهاش كمان سود.
هو توقعهاش means ان هو it will يعني less force, okay? Smaller force on her. Okay. Again, this all has to do with what? With more time. She increases the time of the impact. Okay. So time of impact increases. Time of impact increases. And therefore the force decreases. Okay, good. Shows a person moving across an ice-covered pond to reach a ball on the ice. Explain why this way of moving across the ice is safer than walking.
Because you're decreasing
more
in
surface area.
yeah, you're decreasing the pressure, so it's safer. So the ice won't crack and
Okay, which is correct. Yes, we'll say that as his surface area or area of contact with the ice increases, the pressure decreases due to the equation pressure equals force over area. That's it. Okay. يلا as his area in contact with the ice increases, the pressure decreases. Since pressure and force, sorry, since pressure and area are pressure and area are inversely proportional. Pressure equals force over area. Here, that's it. ماشي. Calculate the pressure at point X due to the ice and water. Nice question. Surface area of the pond is 5 meters squared. The mass of the ice is 690 kilograms. The density of the water is 1,000 kilograms per meter cubed. Point X is 0.45 meters below the ice. Calculate the pressure.
Isn't it
Mm.
pressure is density and gravitational height?
Okay. Pressure equals rho GH. That's all?
we can also wait. Pressure equals force over area برضو عشان
Yeah.
it gave us surface area.
Yes. We're gonna use both of them. خلوكم يا شباب, this is a question worth 4 marks. So probably you will not be using only one equation. Most probably you'll be using 2 equations at least, sometimes even more. But for this question, yes, we will use both equations. We will calculate the pressure due to the ice alone, and then the pressure due to the water alone, and we'll add them up. So the pressure due to the ice is solid, so pressure equals force over area. What's the force and what's the area?
We can find the weight.
We
So
will
we have
find the weight. Yes.
it would be the force, and then we would just divide the force over the area.
Okay. Times 9.8 divided by 5. يلا, someone calculate it for me بسرعة. What's the pressure?
1,352.
1,352.
52.4.
What about the pressure due to the water? يلا, pressure equals rho GH. 1,000 times 9.8 times the height of depth below the water,
Understood.
0.45. Yes.
4410.
What was your question?
I was gonna say that the pressure for the ice was 0.4. Do we have to include the 0.4? Or is that not needed?
لا, it's not needed. Not needed that much. Okay. هنا it's 1000 what 410 10,410 شباب, I did not hear the answer.
I got 4,410.
4,410. Okay. And then we'll just add them up. Which is 5,762. You can write it down as 5,760. What's the unit of the pressure?
5.8 times 10 to the power of 3.
Oh, we can write it 5.8 times 10 to the power of 3. What's the unit? Huh? You keep on forgetting the units. Pressure? Huh? Oh, you haven't been studying.
Oh,
Pre-
Pascal's.
Pascal,
PA.
PA, yes. Okay. The temperature of a fixed mass of gas at constant volume is decreased. Temperature is decreased. Constant volume. Okay. Temperature decreases. What happens and how does the pressure change? Hmm. What happens and how does the pressure change? Any ideas?
The pressure would decrease
Okay. Pressure decreases.
as there's less like kinetic energy.
Okay.
As like increased temperature, there's less kinetic energy, so the
Hmm.
particles have less energy and they collide like less frequently.
Okay. Particles move slower.
So
Hmm.
there's less pressure. There's less force, obviously.
Hmm.
Therefore,
طب,
lower
where
pressure.
where do they collide?
It's force.
And collide with what? With each other? Hmm? Where do the particles collide? That's a really important question. Hmm.
They collide with the surface area and they collide
You have to say they collide with the walls.
with
Okay.
the walls.
You have to say that they collide with the walls or whatever, but never say that they collide with each other. Okay. And they collide with the walls with less force and uh less frequently, for example. Less frequently. Okay? Okay. What is the absolute zero in terms of degrees Celsius? What is the absolute zero? This is quite new. This concept is quite new. We had an equation, a Kelvin. Hmm,
Is it negative 273?
correct. Negative
Okay.
273 degrees Celsius. The equation was Kelvin equals Celsius plus 273. Um, so the absolute zero means that I had 0 Kelvin. 0 Kelvin equals Celsius plus 273. We'll just move this to the other side. So negative 273 equals the temperature in degrees Celsius when the Kelvin is 0. What is meant by the term absolute zero? That's a really important definition. What do I mean by absolute zero?
Like it's the least lowest temperature.
It is the lowest possible temperature. Okay. It is the lowest possible temperature. And in terms of molecules or in terms of particles, what happens to them in terms of their kinetic energy? Hmm.
they slow down.
They
Like,
slow down or they have the least kinetic energy. Okay? The particles have the least kinetic energy possible. Okay? The least. Okay, good. Cylinder 1 contains 350 centimeters cubed of gas at pressure 9 times 10 to the power of 4. The gas is transferred to cylinder 2 and the pressure increases to 1.6 times 10 to the power of 5 pascals. The pressure remains constant. Calculate the volume of cylinder 2.
Would it be the equation like a P1 V1 is equal to P2 V2?
Okay, P1 V1 equals P2 V2. يلا P1 V1 equals P2 V2. Huh. يلا. What's P1 V1? Hmm.
Wait, don't we have to convert 350 into meters?
No, because the
Well,
final volume, the final volume could be in centimeters cubed. That's
so
okay.
it's okay.
It
Volume,
is,
it can meter cubed.
yes, yes, it is a valid
Oh,
unit
okay,
for the
I see.
volume.
So we do 350 times.
Times.
اوكي لا انا بس كنت بتأكد كده like
Mm.
يعني
لا لا احنا we'll leave it as centimeters cubed. طيب. Uh, so you're saying 350 times 9 times 10 to the power of 4 should be equal to 1.6 times 10 to the power of 5 times V2. Is that correct?
yes.
Okay.
And then we'll just like rearrange the formula so it'll be like 350 times 9 times 10 to the power of 4 divided by 1.6 times 10 to the power of 4 is equal to V2 and then we just solve it.
Okay. Can you solve it?
Just 1 second.
Hmm. يلا. Can someone solve it? يلا.
We got 196.875. So
197
yeah.
centimeters cubed. Okay. That's easy. That is easy. Okay. Good. Moving on to the next question. Show that the mass of the air in the room is 79 kilograms. That's an extremely easy question. يلا. What should I do?
Mass
we
is
should
equal
use
to
the
density.
Density equals mass over volume. So mass equals
density times volume.
density times volume. The density is 1.2 times the volume. We already have the dimensions. 4.5 times 6.1 times 2.4. Which is
79.1.
79.1 kilograms, which is definitely equal to 79 kilograms. Good. The power of the heater is 1100 watts. The specific heat capacity is 1000 joules per kilogram degree Celsius. Calculate the time taken to increase the temperature of the air in the room from 16 to 20 degrees Celsius. Okay, it's actually an easy question. It's actually a really easy question. What should I do?
Get the delta temperature. Wait,
Okay,
no.
you have the delta temperature.
Get the difference of the temperature.
Okay, you have the delta T,
or something.
which is 20 minus 16. Okay, 4. What else? What's the equation? What equations should we use? Hmm. Again, 4 marks. Definitely we will use 2 equations. Specific heat capacity. What's the only equation we know of? Okay, again.
Wait,
What is
I thought
the yeah?
I don't know. I thought of it in a way, and no, because we have power, so power is equal to IV, and then energy is equal to IVT. So
But that's the power,
مش
that's the
عارفة
electrical
لو
power.
like
That's the electrical
yeah.
power. What about the mechanical power?
Wait, do we write the equation of specific heat capacity?
Yes, yes.
Okay,
Equals,
so E is equal to mc delta T, and then
okay.
we want to find C, so it's going to be C
No, no, no.
E.
You have C.
Oh, but
Oh, so we're trying to find
we
M.
want
No, you have
we're
M.
trying to find time.
You're
Oh,
trying to find time, but you
أيوة
need
ما
the energy initially. You need the energy.
Okay,
so
energy is what is energy?
Hmm?
okay دلوقتي I understand.
79 times 1000 times delta T, which is 4.
4.
Yalla, what's the energy now? Hmm.
3.16 to the power times 10 to the power of 3
No.
times ثانية 1 ثانية 1 2 3 4
times 10 to the power of 5.
5
Okay, that's the energy. Power equals
Energy
what?
over time.
Energy over
Time.
time. So time equals
Energy times power. No,
energy
energy over
over
power.
power. Oh, 3.16 times 10 to the power of 5 divided by the power, which is
1100 watts.
1100 watts would give me a time of
287.27.
287 seconds. ماشي. Suggest one reason why time is calculated, why the time calculated in AII is the minimum time needed to increase the temperature. Why is it the minimum time needed?
Because energy could be lost into the surroundings.
Definitely. Okay, could be lost to the surroundings. Okay. Um, Figure 5.2 shows the cross-section of a double glazed window in the room. State the main methods of thermal energy transfer from the room. So from the room to outside, which are reduced by this type of window. What are the main
Heat transfer.
what are the main heat transfers? Process.
Conduction, convection.
Yes, conduction and convection. Okay, good. Two seismic waves are P and S. State the type of waves P and S. If you do not remember them, usually, I prefer to say S is transverse, okay, verse Y because S and S, okay, so S transverse. Therefore, P is longitudinal. Okay, we kind of need to memorize them. They're new to the syllabus, so we kind of need to memorize them. The velocity of a P wave in the Earth's solid crust is 7.2 kilometers. The frequency is 4.5 hertz. Calculate the wavelength. Okay, easy. What's the equation we'll be using?
V is equal to F times wavelength.
Okay.
So wavelength is equal to
Hmm.
V over F.
Okay, speed over frequency. Okay. 7.2 over 4.5. Is that correct?
No, shouldn't it be in me? No.
Yes,
Okay.
yes, yes, yes.
Okay.
Kilometers is wrong. We have to change it to meters. How should I change it to meters?
Times 1,000.
Times 1,000.
That's it. 7.2 times 7,200 divided by 4.5 is
1,600 meter.
1,600 meters. Okay, good. Shows a container of oil. A ray of light shines on the surface of the oil. The refractive index of oil is 1.47. Draw the normal line at the point where the ray enters the oil. Okay, this is easy. A normal point هنا. We just need to make sure it is perpendicular to the surface. The angle x is 56. Calculate the value of the angle of refraction. Angle x is 56. How can I calculate the angle of refraction?
هنعمل 1.47 is equal to sine 56 over sine x and then we rearrange.
Okay, but there's one point you said which was wrong.
Wait, isn't it the like two mediums, sine A over the other medium?
Yes, I told she is right, but there's one point that she said which was wrong. Hmm. What's the angle?
You have to do 90 minus 56 because it's I just realized, sorry.
Thank you. Okay, you cannot take the x as the angle of incidence. You have to use this angle as the angle of incidence, which is 90 minus 56. 36. Okay, this is the angle of incidence in air. So n is 1.47 equals sine
It would be
36.
36. Wouldn't it be sine 34?
34,
90
34, sorry, 34.
minus
Yes, yes,
57.
you're right. 34. Okay. Sine medium. Okay, so to find the angle of the medium, we'll rearrange sine
Sine
medium,
34 over 1.47.
sine 34 over 1.47, and then we have to inverse the sign, so the angle would be equal to sine inverse sine 34 over 1.47. What's the angle of refraction?
20.5.
Okay, 20.5 degrees. State the approximate speed of light.
3.0 times 10 to the power of 8.
Are you sure it's 20.5?
انا جبتهاش 20.5.
If no,
Wait, let me redo it, sorry.
rounded to
It's not 20.5. What
Oh,
is it?
22.4. Sorry.
22.4. So I can write it down as 22.
انا كاتبه 22.
3 times 10 to the power of 8 meters per second. That's the approximate speed of light in air. Okay, good. Calculate the speed of light in the oil. Calculate the speed of light in the oil.
n is equal to speed of light in air over the speed of oil. And
Yes.
then we will change it to find speed of oil.
Yes. Speed in the
That would
medium.
be, speed medium is equal to speed of air over n.
Okay.
And then
Speed of air over n, which is basically 3 times 10 to the power of 8 over 1.47. I guess it's about 2 times 10 to the power of 8.
204,000 يبقى تبقى 2.04 times
10 to the power of 8.
Yes. Meters per second. Okay, nice. What's meant by magnetic field? What is meant?
Like the region,
Yes, region.
a region where so the electron, لا
Huh. A region around a magnetic pole in which what? Or a region around a magnet in what? Uh, which other poles? Hmm? In which other poles experience a magnetic force? Either they will be repelled or they will be attracted. That's it. So it's a region around any magnet in which other magnets, north or south, they will be either repelled or attracted. Define the direction of a magnetic field. Define the direction of the magnetic field. It's the direction of what? Huh? It's the direction.
like do we say from north
Of the
from
north.
north to south يعني ولا
لا لا لا, you can't say from north to south. It's the direction of
What's the
what?
force of the north? The direction of the force of the north.
Okay, it's the direction of the force
Mm.
on a north pole in the field. Like, for example, this is a negatively charged metal sphere. Draw 4 lines to show the electric field. يلا. Easiest 2 marks in the exam.
the arrows would be like going in,
Exactly.
right?
Towards the sphere. Moving in towards the sphere. Moving in towards the sphere. That's it. I have a circuit. Some components, R1, R2, and R3 are all identical. Okay, the reading on the voltmeter is 6 volts. Okay. When the diode is conducting, it has zero resistance and zero potential difference. Okay, good. Determine the EMF of one cell. ماشي, that's easy. What's the EMF of one cell?
2
2. 6 divided by 3. 2 volts. Determine the ratio of the potential difference across R2. The ratio of the potential difference across R2 to the potential difference across R3. The ratio of the potential. Can someone think about it? Or can someone tell me how should we solve this question? Hmm. R2 compared to R3. What's the resistance? Not what's the resistance. What's the voltage or what's the potential difference of R2 compared to R3?
Wait, they're
Hmm.
all the same. Like, isn't it 1 to 1?
That would have been correct if they were all in series.
Oh,
Huh? If they
اه
were all in
آه،
series,
كده
yes. Eh,
هتبقى ال1 ال2 1 to 2
why?
علشان it's connected in parallel والR2 هتتقسم مع الR1 وبعدين هترجع تاني للR3 وال2 وال2 هتبقى merged together تاني فالR3 هتبقى الدبل الR2
Okay, okay. Um, okay, quite logical. Since R1 and R2 are in parallel, what happens to the total resistance of them? They are both the same resistance. They both have the same resistance. So the total resistance is divided by 2. For example, If R3 had the resistance of 8 ohms, R1 also had the resistance of 8 ohms, and R2 had the total resistance of 8 ohms. So when they are both in parallel, the total of the combined resistance of them both is what is 4 ohms. So both of them will receive voltage, okay, but due to the resistance of 4 ohms, not 8 ohms. R3 will take a voltage, a much higher voltage. Why? Because it has a much higher resistance in this case. What is the ratio? The ratio would be 4 to 8. What is 4 to 8? 1 to 2. If you had used any other numbers other than 8, for example, if you'd used 100, for example, 100 ohms, it would have still given you the same ratio. So it's always this ratio. If you have two resistors in parallel and one resistor alone, the resistance would be always 1 to 2. Okay? 1 to 2. Okay? ماشي. Or we can write it as a ratio, which is using the column. Now the cells are ايه
I still don't quite get this question.
ماشي again ماشي they're both in they're both in parallel. خلي بالك that R3 is not in parallel with them. R3 is connected in series. Actually, I can draw this in another way. For example, I had the battery, okay? You had both of the resistors initially in parallel this way, okay? And then the other resistor was alone. It was not in series, it was not in parallel with them. So what happens in this instant? Okay, at this instant, what happens? Okay, if you had, for example, 8 ohms and 8 ohms. Okay, let's use other numbers other than 8. If I had, let's say, 30 ohms, 30, and 30, can you find the combined resistance of the two resistors in parallel? Can you find the combined resistance of them? Do you remember it?
Won't we use the equation of resistance and then add them together?
لا.
Wait.
If you have two resistors in parallel, what do we do? Use the product over sum. Is that the
Yeah.
equation you meant? We use product over sum. But again, to make life much easier, okay? To make life much easier. If you have two resistors which are of the same value, if they have the same value, what do? You say, oh, Allah, both of them will have, oh, the combined resistance of them would be half. Okay, it would be half. So without any calculations, they will both have a combined resistance of 15 ohms. Okay? And this resistor has a resistance of 30 ohms. So what
it's
do we
double.
do? Which is double. So if you have double the resistance, it will take double the voltage. It will have double the potential difference. Okay? Due to an equation, which is the potential divider, which is a ratio as well. What is this ratio? If we say, oh, Allah, this is 15 ohms, and the other one is 30 ohms, then the total of them is 45 ohms. What's the total voltage in this case? 6 volts. So we can just cross multiply. You can cross multiply. 30 times 6 divided by 45 would give you 4 volts. And this one, 15 times 6 divided by 45 would give you 2 volts. So basically, the potential difference of them, or the ratio of potential difference is 2 to 4. In simpler terms, it would be 1 to 2.
Okay, I got it.
Okay. Now all of the cells are reversed. State and explain the change in current R1. If the cells are reversed, what will happen to the current in R1?
Wait, how is it? Like, is R1 down? R2 full?
It wouldn't.
The
How's it
R1 is the
reversed?
R1 is the one above, is
Wait,
this.
I-
Yeah, if it was reversed, how would it be reversed?
Okay, so if I reverse the batteries, they will be this way.
Oh, so it's reversing. Okay, I got it.
Wait, so there's not gonna be any current action diode would stop it.
Exactly. The diode will block the current passing this way, so to resistance, the current will be 0. Determine how the new value of the ratio across R2 and R3 will change now.
Won't they become like a series?
Yes, exactly. They will become series. It's as if you've removed this resistor. When you remove this resistor, then both of them will be in series. What will the ratio be now?
1 to 1.
1 to 1.
Mm.
صح. They are in series. Any questions? Okay, moving on to atomic physics. Type of radiation alpha, number of protons 2, number of neutrons is
2,
2. Type of radiation beta, number of protons
0.
0. The charge on the beta, sadly, we need to memorize the new charge on the beta. Okay, we need to memorize the charge on a particle. One charge is 1.6 times 10 to the negative 19. That's why, okay, that's why the charge on the alpha is 3.2 times 10 to the negative 19, because you have 2 protons. Okay, positive 2. What did I do? I said 2 times 1.6 times 10 to the negative 19 gave me a total charge of 3.2 times 10 to the negative 19. Okay, so this number, we need to actually memorize this number. 1.6 times 10 to the negative 19 is the charge on one proton. But since this is an electron, since this is a beta, the charge will be negative. Okay? Sadly, we do have to memorize this new number. Gamma, 0 protons. What is the number of neutrons?
0.
The charge,
No charge.
0.
It's,
Okay. What about,
it's stopped by thick concrete.
okay, thick concrete wall?
Wait, if I write lead, would it be right?
It would be right. It would be right. State how beta decay changes the nucleus of an atom. Hmm. How does it change the nucleus of an atom? Any
Wait,
ideas?
when beta decay, it's the proton gains 1, right?
The protons gain 1, yes.
So then the nucleus is less by 1.
What's less by 1 in the nucleus?
And the nucleus is less by 1 from the proton because the proton gained 1.
لا. No, no, no.
Oh,
The nucleus, the mass of the nucleus remains the same. The mass of the nucleus remains the same. But what happens to the number of protons? The protons increases by 1. Oh, the number of protons increases by 1. By 1. And, okay, by 1. And the number of neutrons decreases by 1. That's why the total mass number, the total nuclear number of the nucleus remains the same. Okay? Radiation detector.
wait, so the neutron would lose 1, and the one that it lost, the proton would gain it? Or?
Yes, basically what happens in the beta decay, a neutron gets split into a proton and an electron. This electron is the beta which leaves the proton, leaves the nucleus, and the neutron is now Oh, what's left of the neutron is a proton. Okay, neutron splits into a proton and the beta particle. Beta particle leaves, and what remains inside the nucleus is the proton. That's it. Okay. Okay.
Yeah.
A radiation detector used in a laboratory detects background rate of 30 counts per minute. Radioactive source is placed in front of the radiation. Initial reading is 550. Half-life is 25 minutes. Calculate the expected reading after 75 minutes. What should I do?
We have to get the number of half-lives.
Okay,
Right,
number
so
of half-lives. Yes.
75 divided by 25 is 3.
Is 3 half-lives. Hello. What do I mean by 3 half-lives? It means that I would divide by 2. Okay.
3 times.
Divide by 2, 3 times. Okay, good. And then, what should I do? I have
We have
3. Hmm.
to do 550 minus 30 الأول and then
Yes. Minus divide plus. صح? Minus divide plus. So initially I will minus 550 minus the 30, which is 520. Then, what should I do?
Divided by 3. But divided by 2 3 times.
Divide by 2, 3 times. Initially it's 260. Divide by 2. 130 divided by 2 again is 65.
Then we add. Don't we add it, right?
Then you add, okay, which would give you a total radiation of 95 counts per minute. If he had said, I need the radiation given off by the radioactive source alone, if he had said that he wants the radiation given off by the source alone, you would have said 65. But since he's saying the radiation or the reading on the detector, then you have to add the background radiation again. Okay? Oh, well, 2 safety precautions taken when moving, using, or storing radioactive sources in the lab. We have seven.
We have to use like hazmat suits or like
Ah,
protective gear in
oh,
general.
definitely we use hazmat suits, but we don't write it as we use hazmat suits. We say, like, use protective shields, for example. Okay. Use long tongs, for example. Use safety gloves. Okay. Don't touch them directly
And
using
then
your hands.
yeah, and then for storing, we would store it in a lead box.
Okay, store in lead
Away.
boxes. Store in lead boxes. We can say decrease the time of exposure. Decrease the time of exposure. Hello, good. And you can use long tongs, wear safety gloves. Okay, moving on to space physics. State the equation that defines the average orbital speed of a planet. State the meaning of any symbols you use. What's the orbital speed? What is the orbital speed of any planet?
Speed is equal to 2 pi
Yes,
r over 2.
yes, 2 pi
Over
r
time.
over t. What's r?
R is the what was
is
it?
the radius.
Radius,
Radius.
yeah.
Yes, it's the radius of what? Of the planet?
No, of the orbit.
Of the orbit. You have to be specific, huh? The radius of the orbit. And what's the capital T?
The period.
Okay.
Of, like the orbit.
Period of the orbit. Okay. Suggest why countries that are a significant distance from the equator, above or below, experience significant temperature variations throughout the year.
Because like the rays of the sun are struck at like different angles.
Yes, they do strike them at different angles. They do strike them for different periods of time throughout the whole year. Okay. sun strikes the countries, them at different angles and for different amounts of time. Fill in the gaps. Fill in the gaps of what? Of a star much more massive than the sun. The stage that follows the stable star. Initially, it was a stable star. What's the state that follows this stable star? Hmm. If it is a massive star, what's
The
this?
red giant or
Red giant? Can you say red giant? Or do
su-
you, huh?
red supergiant?
Supergiant. You must say that it is a red supergiant. Okay. Why? Because the smaller stars, such as our sun, will eventually become red giants. But the massive stars will become red super giants. Then they explode as a supernova to form what happens after the supernova? Hmm, we need to memorize them, huh? What happens after a supernova? What, so
It,
what remains after the
the,
supernova?
the
Hmm?
nebula,
Dwarf
nebula,
or
Nebula. لا. Nebula remains after nebula remains after a an explosion. Explosion, شباب, if you think about any explosion, if you think about even explosions here on Earth, uh, something explodes. And then there's a lot of dust, a lot of things that remain from the explosion. These remains of the explosion is what we call in space physics nebula, the remaining of the explosion. Okay, it is the dust and the molecules and the whatever that is scattered throughout the whole space. This is what we call a nebula. This leaves behind what? If it is a red supergiant, what does it leave behind it? Hmm.
black hole,
black hole.
Black hole
and
or,
neutron star.
yes, or a neutron star. Can a red giant leave behind a black hole or a neutron star? Hmm. كده نرجع يعني for example
No.
our sun, can our sun leave behind a black hole? لا, it cannot leave behind a black hole or a neutron star. Okay, a galaxy is moving away with a speed of 33,000 kilometers per second. The value of the Hubble's constant is 2.2 times 10 to the negative 18. Calculate the distance. Give your answer in light years. Okay, what should we do?
Um, it isn't Hubble like speed over distance, and then we would change it to
Okay,
find
okay.
distance.
Hubble's constant h naught equals speed over distance. We need to find the distance, which would be speed over Hubble's constant. Okay. Hmm. What's the speed?
Um, the speed is 33,000. Wait, we
33.
have to.
Huh.
Does it have to be meters, right?
It has to be in meters.
Yeah. So it would be a really long number.
Times
Times 10 to
1000.
the power.
Times 1,000.
Okay. Which is يعني 33 million. Over Hubble's constant, 2.2 times 10 to the negative 18. This will give me an extremely huge number. Okay, just state it. What is the number?
1.5 times 10 to the power of 24.
Times 10 to the power of 24 meters. صح? 1.5 times 10 to the power of 4 meters. How can I change this to light years? Hmm. Do you actually remember the value of a light year? Hmm. If you don't, well, you can memorize it. If you'd like, you can memorize a light year. That one light year is equal to 9.5 times 10 to the power of 15. Okay, you can memorize it if you want to. Okay, but if you don't want to, you don't have to. You can actually calculate it. How can I calculate a light year? Wallahi, one light year is equal to light year. It is a distance, and distance equals what? Speed times time. So the speed of light, 3 times 10 to the power of 8 times the time taken in 1 year is what? 365 days times 24 hours per day times 60 minutes per hour times 60 seconds per minute, which would give you a total number of 9.5 times 10 to the power of 15. Okay? This is how you can calculate the light year. Light year speed times time, which is easy. Speed of light times the time in 1 year, but you need to find this time in seconds. Okay, so I have the distance in light years and I have the distance in meters. All I'll do is what I'll divide them. 1.5 times 10 to the power of 24 divided by 9.5 times 10 to the power of 15. Can someone find the final answer?
It's 1.57 times 10 to the power of 8.
1.57 times 10 to the power of uh, are you sure it's 8?
Um,
9.
Hmm.
لا هي لو عملت لها راوند يعني هي طلعت 1.5 يعني هتطلع 157894736 اعمل لها راوند ل 1.6 واعمل التانية times 10 to the power of 9
Okay.
صح؟
Yeah, it's 10 to the power of 9. Just make sure into you calculated it times 10 to the power of 9, not 8. Okay?
okay.
That's it.